Good afternoon, all. I am Lou Galante with the Iowa APA Professional Development Committee. We welcome you all to today's webinar and appreciate your attendance. And our hope is that you find this presentation enjoyable and practical to your organization's operations. Today's presentation is by ISG, and the event manager, Jordan Lawson, was graciously helped us set this up back in July. The presenters are Andy Brendel and Aaron Chisholm. The topic today is leveraging technology for campus operation and planning. Without further ado, take it away, Andy and Aaron.
All right, thank you, Lou. Thank you, IAPPA. I'm Andy Brandel with ISG, and we hope you find our presentation educational today. We're leveraging technology for campus operation and planning. I'll just do the quick plug. I guess ISG, we're a full service engineering and architecture firm with offices in Iowa, Minnesota, Wisconsin, and South Dakota. So thank you for joining us today as we run through some of the technologies that we use to help our clients for both data management, operation, maintenance, and planning. We're going to run through slides here, talk about what the technology is, some applications for it, how can it apply to you all with campus planning, and then look at some new technologies as well. So if we can jump to the next slide here, Aaron.
And if anybody does have any questions during this presentation, on the right-hand side, there is a Q&A box you can click on and submit your question, and Andy and Aaron can answer those. Just wanted to mention that. Thanks, Andy.
Oh, thanks, Eric. I already forgot that. So we don't need to spend much time here. Again, I'm Andy Brandel, Senior Vice President at ISG, and with me today is Aaron Chisholm, our GIS Manager. So jumping on, like I said, we're going to start with some of the technologies. You can go ahead to the next there, Aaron. Some of the technologies we use. One thing at ISG, we do work very hard to stay ahead of emerging technologies. We do have an applied technology group that ranges from GIS, visualization, drone, videography, pipe camera, and kind of everything in between. So we try to stay ahead of that with that team. Today specifically, we're going to talk about GIS, 3D scanning, drone thermal imaging, and kind of some applications we've used on how to apply those technologies. But first, I'm going to have Aaron run through just a little bit about what those technologies are before we work on applying them. So Aaron, go ahead.
Absolutely. So obviously I'm the GIS manager for ISG, so that is definitely my forte when it comes to the technologies that we have here listed. The first technology we'll talk about briefly is GIS. I know it's kind of a complicated term to try to describe to people, but GIS stands for Geographic Information System. So it's taking geographic data and being able to use it to create maps, access, maintain data, and analyze it. And with GIS, we have a lot of applications that allow us to best use GIS data to maintain our systems. So here's a quick example of some two maps that we made. As you can see here on the left, there's a map that shows locations, it shows roads, it shows average daily traffic on those roads, it shows traffic signals. And you can take all of that data and kind of look at pieces of it and be able to bring everything into one map. Then at the bottom right there, you see a map that shows parcel locations and with that, analyze 2-mile buffer from that location. So you can take all the data and apply some metrics to it and get results. We do have a full 3D scanning team. We use a variety of different techniques, and we'll kind of go into some 3D scanning technologies and more applicable reasons for it. But you can see here we have some different types of 3D scanning equipment. We have the top left there, the Faro Focus 3DX, which is a highly accurate 3D scanning system. It shoots out essentially LiDAR or point cloud points to different objects and then retrieves them and finds the distance and shapes and things like that. And then we have the GeoSlam, which is a more mobile unit. The Faro focus is one thing that stands for 2 minutes. It does an entire rotation, and then you have to move it to a different location. Whereas the GeoSlam, you can just walk at an average 3-mile-an-hour pace and collect 40,000 points a second. We also have a manhole scanner, which is combined with the GeoSlam, but has a 360 camera attached to it, and we just kind of gently slide it down a manhole and capture 360 videos and a 3D kind of point cloud of what that manhole looks like. And then lastly, we have a pipe crawler, which is something we send down pipes, obviously, and acquire video and photos, and we can look for any issues in those pipes and then be able to find out exactly where those issues are and bring it to that client. The next is drone and thermal imaging. We have quite a lot of drones, and we have a pretty good drone team. And with those drones, we can fly most locations and gather video, gather photos, and even look at photogrammetry, get kind of 3D meshes of locations, and really use high resolution drone video and photography to capture a lot of different things, including a 3D textured mesh and things like that. So we have quite a few different drone options that fit different needs, and we have a thermal drone, and we have a full-time drone pilot and a team of drone pilots that fly all across the country.
So moving on,
Go ahead, Andy.
now that we've kind of jumped into what those technologies are, we wanted to show some applications. Now, want to note the applications we're going to show are not all higher ed examples. Some of them are. During this portion, we wanted to show you more of the most up-to-date technologies and examples we had, and then the next section we'll actually jump into how to use them more for campus-specific planning, operations, etc. So if we jump to the next slide, which as soon as I said that they're not all higher ed, we start with one that is. First off, this is actually a GIS system for St. Olaf College in Northfield, Minnesota. It is, St. Olaf's been a long-term client of ours, and Aaron's going to show a demo here, but we really just wanted to show one example of mapping and data management. They actually came to us. We've worked a lot with them because they said we have a myriad of old paper maps that may or may not be complete and old infrastructure. And actually one of the drivers was one of their folks was retiring, and he knew where most of it was in his head, and it wasn't actually accurately shown on maps. So we went in and did a GIS mapping application, which Aaron will briefly show here.
Okay. Yeah, so let's kind of go into a quick demo here with that. I'll bring that up here. So as Andy kind of mentioned, St. Olaf College brought to us a couple different concerns. One of them being, hey, we have a tunnel system, a pretty expansive tunnel system, but we don't exactly know where they are on the surface. You know, we don't exactly know where on the earth the tunnel is underneath you without doing something like what we did. So we took that 3D scanning tool, the GeoSlam that I briefly mentioned, the mobile unit, and then we walked all of the tunnels, and we're able to take that data and put it back on the surface of the earth so we can know exactly where those tunnels are on Earth's surface. And then we put that in a map so that they can access it and look at it. And I'll kind of go into that in a second. But one of the other things that they wanted was their water system, their pipes, their valves, their hydrants, all that stuff, GPS and put into a system that they could access and look at so they knew exactly where everything was. And then we're hoping to continue that with things like fiber optics, things like sanitary and storm sewer systems, and hopefully grab all of that data and put it into a digital copy so that they have access to it. They can look at it, they can, you know, help do maintenance requests on it and things like that. So, so far we just did the tunnel and the water main system, but it's a pretty good system. And the one benefit about using GIS is we were able to get the entire tunnel system and GPS, high accuracy survey grade GPS of their entire water system in one full day, which was pretty amazing. So if we kind of zoom in here, you can see that they have the tunnel system as the first layout here. And with that tunnel system, we did the GeoSlam and 360 video. So here's the example of the tunnel system and a 360 video. Let's move it along here. So this is a way, what's that bad spot? This is a way that they can walk the entire tunnel system, and it's a 360 video, so they can look all around and they can look here. We can see that they have the condensate and the fiber up here in the orange conduits, and they have electrical and old telephone lines, and they're able to virtually walk through the entire tunnel system using this application. They also have access to the actual 3D point cloud, which will show up here in a second. And all of this was from that one walkthrough. They can kind of navigate and they can kind of look at, okay, so here's the tunnel system. They can kind of zoom in and play with it. You can kind of see that we caught some buildings on the outside and things like that. But they can kind of look and interact with the data and see how the actual tunnel system looks, you know, in elevation and things like that. And then obviously we have a kind of a 2D version of it here. You kind of see the tunnel connects to a few buildings, and they can kind of interact and see how the tunnels connect and where exactly those tunnels are. And then obviously with this system, we were able to put it on the surface, and they can go out with their phones and look at this map and look exactly where they are.
And so that was a good application with 3D scanning. We can actually bring that into Revit as well. So if they were doing modifications to their tunnels, or there was a building project where they wanted to, you know, a campus building project, we know there's a tunnel there. Now we have that data and can put it into any model, bring it into CAD, etc., given the data we collected that they already have.
Absolutely. And then we also have in here all of their utility system, like their water system. I'm going to turn off some of this stuff here. And now we can see curb stops, we can see valves, we can see water mains. This is the stuff that we survey grade collected out in the field, and we're able to take what data they could provide us and create a system that they can look at. And then with all of those, we can look at, let's look at things like hydrants here. So if you click on a hydrant, you can see that we even took photos of each one of them so they can kind of visually look at them as well. And then as we go about and we want to update the system, we can retake photos and we can use this as kind of a maintenance plan. We can throw in data like what's the condition, what's the manufacturer, is there flag presence? If we knew the installation year, which for this one we didn't, we could kind of start working on a maintenance plan for some of these things by understanding when it was installed, what's maybe an average lifespan of a fire hydrant, and then be able to use this as a planning tool to better, you know, plan their assets. It's kind of an asset management system for them. So that's kind of the water system and the tunnel system. We also have a bunch of other cool tools in here. You know, obviously we wanted to provide them with some editing capabilities, but they were nervous about being able to edit their own data. They didn't want to accidentally delete anything. So we did provide some edits for some points, lines, and polygons that allows them to add their own points, lines, and polygons to make suggestions, to make edits without actually editing the data. They also have things like a draw tool on here where they can zoom into an area and use this as a multifunctional app and you know, do drawings and things like that and say, hey, I want to check out this, you know, this parking lot for some reason. They can add annotation, and they can even do custom print jobs that will print with their logo when it's customized printing, so that they can have access to the data and be able to print it and look at it here. I'll show you with even their custom logos and legend and all that other stuff. So it has their custom logo, custom title, things like that. So they can even use this tool to print, you know, good quality map products. For internal use, external use, they can save this as a PDF, they can print it, whatever they want to do. So it's a pretty cool tool as well. And then we even have filtering options in here if they wanted to look at things like any hydrants with a condition of fair or poor, it'll only turn those ones on. So you can kind of look at how your hydrants are doing. And then we also have the option of doing custom filters, where if they want to look at, you know, if they had installation dates, for example, for all the hydrants, I want to see any hydrants like this, any hydrants installed in 1 year, 1990 or something of that nature. So it's a pretty multifunctional tool that allows them to kind of take control of their own data. And like Andy pointed out, most of the data was in one guy's head. So we wanted to get it on, kind of get it into an app that's usable by everybody. So Anything else to add, Andy, for this?
Nope, I think we'll touch on it again kind of when we loop back to it.
Perfect. Perfect. All right. All right. So the next thing I think we'll talk about is using Survey 123 and Collector. This isn't exactly a higher ed example, but I think it's a very valuable example that shows the power of using GIS in different platforms to be more efficient and better utilize technology. So I think we'll start with the demo on this one as well. So for this example, I'll show it here. We got hired to do a sump pump inspection for the entire city of Redwood Falls in Minnesota, and with this we needed to touch every single home. And so we did some data on the back end, but it allowed the front end of the data to look easy and efficient, which is what we're looking for. So like I said, this project hasn't exactly started yet because obviously COVID has changed a lot of things, but this allows our inspectors to go parcel by parcel and be able to tell whether it has been inspected or hasn't been inspected, and can kind of be a map checkoff list for each parcel. So what they would do essentially is click on a parcel, it tells you the address, they confirm the address, and then we have a Survey 123 form. And Survey 123 is very similar to like Google Forms or SurveyMonkey or something like that, but it's a GIS-based form. So they would be out on the iPad with this. These are two different apps that would talk to each other. And then we have all the information automatically filled in. So the date would automatically fill in, the time would automatically fill in, the reports would be by whoever person was making that report, drop down. And then property address, owner on record, phone number, cell number, email, all of that information would automatically fill in based on the parcel information that was filled in. Then they would just have to fill out a few sections here. If it's a sump pump inspection, what's the compliance look like? If it's a dual valve system, or there isn't a basement, or there's not a sump pump, this would all, be something they could check. Additional comments, they could take a photo, they could upload multiple photos, and then they could even hand this over to the residents and be like, do you agree to receive emails? If yes, it will just automatically fill in the one from above. And then if it is a failed inspection, they have 90 days to kind of fix it, and then contact City Hall again, and then they could sign on the line with the iPad and then press submit. And then they could go back to the map, say edit, and then they would say this inspection is complete, close, and then it turns green. And that's a way that they could kind of walk through the entire city and know which homes have been inspected, which homes haven't been inspected, and be able to kind of maintain that quickly and efficiently. By having all of the data kind of auto-fill into it, makes it super efficient. And like I said, we haven't exactly gotten started with the project yet due to COVID, but we think that this will be a really easy way to kind of maintain that project. So that's kind of the Survey 123 collector piece of it. But in addition to that, I'll move on to the next slide here. The next piece of it was we were able to set up what's called a webhook. And so what happens is as soon as they submit a survey, it goes to a router. And this is all done on the web. And when it's gone through the router, it will go through a PDF creator. And if it's a failed inspection, it will be emailed to the City Hall directly. Say, hey, you have another failed inspection. And if it's not a failed inspection, or just if it's an inspection, it will go to a share file link where we just kind of drop all of these PDFs as a report. I'll show you what that looks like here on the next slide. It looks like this, where all that data is kind of filtered into a PDF report and kind of fills in these lines here, right? The property address, owner name, phone number, all that's kind of filled in per parcel. And then it's kind of a blank form, and then all of the data from the Survey 123 fills into this with pictures, the signature, everything like that. And so that allows us to create these PDFs instantly, and then they look professional, and then they kind of filter through whether it's a failed inspection or whether it's it's just normal inspection, and it drops in the share file. So they have a PDF report of every inspection. So definitely a very valuable tool for us, and I think it's going to be a really nice system when we're all complete and ready to rock and roll with it.
The next technology we'll look at, this is a combination of them, I guess. again, not a higher ed. This is actually a project we did for a financial institution, but we did facility and location assessments. So what we did was facility assessment. We actually went and toured all their facilities, did physical assessments of all their facilities with mechanical, electrical, civil, all disciplines, to put a facility assessment report together. And with that, obviously it was physical inspection, but we also did use 3D camera to get 3D images of all of them, and then put it into a GIS story map. Along with that, we also did a location assessment, which again, easier to maybe understand with looking at the map here, locations over 3 states. But as we'll dive into as we get a little further, same basic outline workflow can work for campus planning, which we'll get to. But wanted to show, this is a GIS story map that Aaron can jump into, show another demo. Again, just trying to show some of the technologies and how they work before we get more into exactly how they can work for you. So again, in this one, we toured 28 different buildings, did facility assessments, and then did location analysis of 50 plus, something like that. And then the deliverable was this story map, which was meant to be a presentation tool, but also meant to house all of the data and be in a format that we give to the client and they can use. Very similar platform to the GIS for St. Olaf we used. And then we also gave them, I guess, the GIS platform like St. Olaf with all the data in it as well. So go ahead, Aaron.
Yes, absolutely. So as Andy kind of pointed out, one of the things that they wanted from the very beginning was to have a presentation tool that they could just work with and they could just run with. And that was also the deliverable product. So this worked out very nicely. It's a very interactive custom story map application that we built for them, and it's housed on our server. And what it allows them to do is look at the executive summary up here and kind of go through how we ranked each one of their locations, and then look at kind of the executive summary stuff. But it allows them to click on individual locations and then zoom to that location in the story map. So here's the Sparta location, which we did do a facility assessment for, and you can look at the scoring and you can look at each individual location. And then with that comes the 360 tour as well, 360 camera. We didn't do a 360 video tour like we did for St. Olaf, but we did do a 360 kind of camera, so they can still pan around a little bit and kind of look at the location. They can look at the lobby. They can look at the interior as well. And they can kind of look at each location and kind of get a better grasp of how each location looks. And then with that, we also did include the full PDF report. So they can go to the Sparta, they can click on this, and then they can kind of visualize the entire PDF report for that location. And then if they want to go back to the home, they can go back to the very beginning, and then they can look at the next location. Like for example, Sycamore, Illinois. We did not do a facility assessment. We didn't actually go to the building and look at, the guts of the building and determine, how it looks. But we did a location assessment, which is where we took all of their data and a bunch of other data, and we kind of just analyzed each location compared to each other, and we kind of, assessed how that branch of their company is doing. And this one is in the good, right? We kind of had a very simple color code system of 5 colors, and this is a fairly good location. And then obviously we go back out and you can click on any one of them and kind of do an interactive experience with each location. And then also at the very end, we wanted to include all of the data that we already had. So we included the full combined 900-page facility assessment report. If they wanted to print it all at once or something of that nature, they wanted to look at all locations. It's 900 pages exactly. We also did create, we also used location analysis and GIS to determine what might be an ideal location. So we looked at 29,000 cities in the US. We narrowed it down to 2 after a few variables. Kind of quickly, variables like, is the population over 18,000? Yes, okay, so that knocks down a few cities. Does it have, what's the internet look like for the locations? Is it close to an interstate? Does it have grocery stores, things like that? So we were able to do that as well. And then we have a whole bunch of maps that we saved in here as well to kind of look at current locations of employees and drive times around their current locations. We could look at, kind of a drive time analysis map, which we'll kind of show as a higher ed example here in a little bit. But here's a 0 to 10 and 10 to 20 minute drive time from a certain location. So all of that's kind of built into one app and allows them to have everything at their fingertips. They don't have to try to find out where that email was from a PDF or where that Dropbox link is or anything like that. So it's all here in one location and allows them to, kind of interact with it, but also provide a presentation tool similar to something like a PowerPoint, but much more interactive. That's what we were hoping for. So it turned out pretty nicely. Right. Move on to the next one here, Andy.
All right. So now that we've shown how we apply some of them, again, not necessarily in higher ed examples as it relates to our audience today, but I'm sure you've noticed some applications that maybe could transfer already, and we're going to run through some of those. So if we jump to the next one, next slide, going back to the St. Olaf GIS, Aaron went pretty in depth there, and I think from a data management perspective, I think that did a very good job showing exactly the data management capabilities of that system. That system currently, like I said, we gave them editing capabilities and started with, like Aaron said, water, tunnels, but we did have campus-wide survey where we added sanitary, but we haven't added all the data into it yet. And as we do projects, we've also done pavement management here, looking at adding in. So from a data management perspective, very good tool, and they've been very pleased with it, especially as they have had some transition in staff and being able to jump in and have everything at their fingertips. So from a data management perspective for campus operations, this has been a very good tool for them thus far. Taking that a step further, we talk about execution a little bit on facility and infrastructure maintenance. The reason we went into the survey 1, 2, 3 and collector is not that there may or may not be inspections that would need to be done on campuses, but we also use this. We have it set up. We have a pipe crawler technology, and we actually use it as a form that can be filled out by a client to book an inspection or book our pipe crawling and actually use it as a tool as basically online ordering. So the reason we bring it up here as it relates to campus planning is it could be used internally and externally, and we've started to play with this. Again, the Redwood Falls is an example, same platform, but a little different use in that it could be used internally with some of your facilities folks going, a repair is needed here, go into the Mac, click on it, go into survey 1, 2, 3, fill out the form, and the work order can get emailed to anybody. It could be your preferred vendor, it could be the superior or whoever orders the maintenance or on-site staff that does the maintenance. But the nice thing is then it's all housed in the system. It's essentially using the data management and adding asset management, and you could use it. You could fill it out and have it emailed directly to the contractor or to really anybody. So whether it's internal or external, that's a tool that, again, you wouldn't need the full GIS system we had over here. You could still do it in collector, correct, Aaron? Record a location,
yeah.
Punch it in. But if you could stand alone, but putting them together, you have an even more powerful tool because you can zoom in, show them the exact location. You could, show them distances from other things, and then generate work orders. Maintenance, again, internal, external. So just kind of trying to show how combination of those, or they could stand alone, as we look at execution on facility infrastructure maintenance. If we jump to the next here, going back to the Compeer financial and how we use GIS story map as well as facility and location assessment, We're going to start with capital improvement planning. Again, here we see Compeer financial executive summary, which Aaron did a good job running through. Now, instead of this executive summary being 28 different locations in different cities, that could very well be the 28 buildings on campus or whatever, 28 streets on campus, what have you. You'll see down in the bottom actually is, again, using that St. Olaf example, is a map. We did a pavement management plan for the campus as well, which could be plugged into a story map similar to this, could be plugged into the facility assessment examples, but just showing again how that platform, yes, the map behind us shows 3 states, but it could easily show the map down in the lower right-hand corner and zoom in and click on any one of these attributes instead of any of those. Still, again, have 360 camera, etc. And then the 2 pieces of it, you know, focusing here for capital improvement planning on the facility assessments, you know, any inspections that are done, improvements that are done. If we jump to the next slide here, Aaron, you know, this is just some of the data that was housed within that, and we use a program called Power BI to generate different graphs. You'll see on the left showing anything from this red, yellow, green is priority of, you know, 1 being what number priority that needs to be handled within 1 to 2 years, potentially safety issues, etc. You know, a little longer out or farther long-term planning. And then you can just see again, Aaron showed some of the factors we use that were important to that client, but the rubrics on the right and the ranking of that with a facility assessment could easily be used for, again, campus, and whether it's a ranking system you put in place to prioritize, or we set a priority system prior to starting. And then if you jump to the next slide here, Aaron, again, without jumping in, this again, not a higher ed example. This is actually a K-12 facility that had multiple facilities, but you can see here we mapped out a 10-year capital improvement plan for them, outlays all of the locations, etc. So again, taking what would have been a more traditional facility report with a whole bunch of pictures you sort through and try to tag whatever. Now we can go in with GIS, with Collector, and put that all into story map, get your different outputs, make it more accessible, and use it as a capital improvement planning tool as you look at whatever facilities that may be on your campus. So as we jump ahead here, so that was, you know, from a capital improvement planning perspective, which again, you know, understanding the best way to outline to, you know, all of these facilities folks where you need to, you know, where improvements are required and where capital investments needed. Jumping ahead, another use of the technology is operations and planning. These are some of the tools we used in the Compeer location analysis. We also used them here. Again, we're trying to just show consistency with St. Olaf with off-campus students. We actually used some of the drive time mapping similar to the location assessments we did for Compeer. In this case, we actually were looking at new student housing on campus. So what we did is we were given all of the securely given all of the locations of all of their students that lived off campus and looked at a drive time analysis. And this is just one of the heat maps for drive times. And actually, if we jump, might as well jump to the next one just to show another example here, Aaron. This actually shows, using GIS, we showed the most efficient route for those off-campus students to get to campus. And what we actually used this for was a few things. One was for a required traffic and parking study, especially in the time of COVID when traffic numbers were down and students were not on campus. we worked with the city and the county and said, hey, traffic numbers are down, students aren't coming to campus. Can we use this GIS technology and some of our location assessment tools to plot where they are coming from and what the path is for them to get on campus? Now, can we guarantee that every student's going to go that way? No, but can we guarantee that students usually aren't early to class and are probably taking the shortest, most efficient route? Yes. And this is just one example. Obviously, there's a lot more data into this. Using GIS uses traffic signal data, I mean, to show literally the most efficient drive time. But these are just a few examples. And what we're trying to show here is jumping to the next slide, Aaron, which doesn't show a lot of mapping, but using Compeer as an example, and also this, we found that some of the location assessment tools can be used for campus master planning. In that case, we used them for parking and traffic planning, not only for improvements to accesses to campus for vehicular, but also pedestrian circulation, looking at how students most efficiently come into and off of campus. We've looked at bus routing, not a lot for higher ed, but for K-12 clients. Same basic, you could look at, well, where are we picking up students? How do we look at bus routing? We've also used it for, we put campus housing planning or campus expansion planning. If there are needs to, where should parking lot go? Where should housing go? Where should, if there's an evaluation of purchase of additional land? These are all tools which we could certainly provide more data on, but we can use the GIS variables and location assessment to help make informed decisions with the data that's available, and also with input, obviously, from the client of what is important, what is the end result. As we've done these for other clients, we Aaron and I can kind of joke about it of we don't know what it's going to look like at the end, because we don't know what the client's main goals are. It might be, we're looking what's the best location for a new housing to make sure that there's 4 off-campus housing locations that house most of our students, and what are the routes they're going to take, or any sort of things there. So anything from master planning to transportation, just another way we looked at that we can use GIS and location analysis tools to hopefully help with campus operations. With that, so we ran through, and I think we're doing pretty good on time to hopefully leave some time for questions. And again, if there are questions, please do post them. I know we're running through a lot of data and a lot of information quickly here. So please, and if we don't get to them today, we'll certainly follow up. So really what we've run through here to this point is some of the technologies we're already using for whether it's asset management, data management, maintenance, campus planning, etc. And those tools continue to evolve, and we continue to use them in additional applications and continue to push the envelope as they change, new technologies come on board. What we're going to jump into is what's next here a little bit is Aaron is going to talk a little bit about some emerging technologies that we haven't fully used yet, but we're starting to look at. And part of the reason we're showing those is all of the applications of technology that we just talked about. These would be additional tools to just take them, I guess, to another level, potentially inside your facilities with higher accuracy, as well as some other things. So with that, I will let you jump into what's next here, Aaron.
Sure. So as Andy pointed out, we're not using every GIS software that's known to man. So one of the newer kind of GIS softwares is something called ArcGIS Indoors. It's an indoor mapping platform that allows you to do asset management essentially inside, which is new. Obviously, GIS is more of a broader based system that kind of goes with outside mapping. If you do anything with GPS, that's using satellites, and you don't have any satellite signal indoors. So using a GPS doesn't really work indoors necessarily. So that's why mapping has kind of historically been always outside. But Esri, the #1 GIS company in the world, has recently explored something called ArcGIS Indoors, where they use GIS software to create a digital twin, they call it, of your building. You can get as granular as every light bulb, every socket can be categorized and mapped out. Every building, obviously every building, but every room inside that building. You could even combine systems, like people who use Google Home to turn their lights on and off. You could use that same type of software integrated with this, and then you could turn off, lights in a certain room, or you could combine Outlook into it, and you could schedule a conference room from this same app. You could figure out where people are. There was an example that was shown of ExxonMobil's headquarters in Houston, Texas, where they had an entire campus, right, of about 15 or so buildings, and this guy, you could check in and allow yourself to be, present, and people could know where you are on campus and which room you are. And he wanted to go talk to this person who's in the cafeteria 3 buildings away, and he was able to route the most air-conditioned way to get to that person. So it's very intense, and we haven't quite explored it to the fullest extent yet. But that's something that's coming. Obviously, you can get as granular as you want, or you do much more of an overview approach to this. But here's another picture of what that might look like, where you could map out, the quickest way to a certain location, and you could assign a whole bunch of different things to rooms and outlets and light bulbs and whatever. But it's a new software that's coming out that allows you to do kind of internal asset management, on top of external asset management. So, yeah, that's something that's coming up, and it's something to kind of be aware of. I don't think it's really hit the campus or higher ed campus facilities quite yet, but I think it's something to kind of just keep an eye on, and that's definitely something we'll be exploring more and more to kind of fully understand its capabilities.
Well, and just to jump in on that quickly, Aaron. I mean, part of the reason showing that again is imagine all of the infrastructure mapping exterior. Same thing. You could put all or some or whatever extent here, could still use the same collector 1, 2 or survey 1, 2, 3 and collector for asset management. Right now we should note with facility assessments, we are currently using a program that we can load a floor plan and then on an iPad and click a spot of where we are, take a picture and take notes, and that's how we're doing our facility assessments. But again, there we need to load the floor plan prior and then understand what room you're in, understand what room you're facing, drop the pin in that spot, take your picture, etc. So we are using technologies similar to this. It's just they can't map you inside right now, the other technologies, whereas the ArcGIS Indoors platform actually essentially makes your building a smarter building and can map you interior as well. So we are using some technologies, but it's not anywhere near this right now when it comes to facility assessments and some of those things. So
yeah, and on top of that, to kind of briefly talk about the accuracy inside, obviously we can't use GPS inside because you don't have access to satellites, and that's the entire, that's exactly how GPS works. Whereas ArcGIS Indoors is exploring technology called Bluetooth positioning systems, kind of like global positioning systems, where you could put Bluetooth mounted receivers on the wall, and then connecting to the Wi-Fi or connecting to the Bluetooth allows you to ping your exact location very accurately throughout the building. It's kind of a newer technology. It's something that is being integrated with this. But like I said, it's not something we've quite explored yet, and it's just kind of a emerging technology. But that's how they're trying to get around that hurdle of being able to accurately locate you inside instead of just outside. So it's kind of a cool technology coming on. And then I think the last kind of what's next is a kind of a cool example of using 3D. Everything that we've seen in GIS is kind of a 2D platform, right? You look at it from kind of the, the on top view down, and we have recently kind of explored more 3D analysis that allows a better way to look at things. So here's an example. I'll do a quick demo real quick where ISG in our Des Moines office has recently looked at moving our Des Moines offices to just one location in Des Moines. And one of the things we want to look at was the shape of the roof was kind of unique. It's kind of got this slant here, as you can see. And then one of the things we were exploring was maybe using some solar panels on the roof to look at how the sun might affect the solar panels, especially during low light times of the year, like now, November through January. And so Des Moines has a restriction on height limits of the buildings, and so that's 75 feet. So we built an imaginary 75, there's a current parking lot here, but we built an imaginary 75-foot building here just to kind of see how the sun would affect shadows during low light times of the year. So there's a cool little daylight kind of tool here. So we go to 2019. Let's go to kind of see how the sunlight changes there. So to go to December 2nd, 2020, you can kind of play through what that sun would look like, especially with that building there, what those shadows, how those shadows would affect during what time. So there we are, we're at 5 p.m., it kind of comes back out. Here we are at 7 a.m., and we can kind of see during this time of year how shadows would affect this building, which is kind of a cool tool there. You can kind of zoom around and look at it in a 3D view. And then you can also, if you wanted to, you can even clip through. I'll pause that for a second. Let's make it daylight there. All right. You can even analyze it a little more, and you can kind of clip down, and you can kind of see our Revit models here. And there's another cool tool that we have where we can kind of look at the building in different, there you go. You can kind of look at the building, and you can kind of see the internal guts and everything, because this is a building that we have in Revit, because obviously, it's going to be a new office location, so we wanted to see what the floor layout looks like. And this tool allows us to kind of dig into it a little more in a 3D view. And obviously, like I said, this is an imaginary building we put up, so there's no guts in that one. But this one, there are guts in, and we can kind of look at all of that. So we were able to take the building footprints for Des Moines, super basic buildings, but those are the actual heights of the buildings based on LiDAR that we collected. And those trees are exactly where trees are and everything too. So it's a pretty good replica of this part of Des Moines. Obviously, it's not the whole of Des Moines, but it allows us to look at, kind of look at the daylight, especially with something like a solar study. This is a good tool that allows us to look at different times of the year. And we have, built-in slides down here. Look at noon, November 21st, a month before the winter solstice, a month after, and then on the winter solstice, what noon looks like for this location. So it's a pretty valuable tool. It's kind of a cool tool. And it didn't take terribly long to build, but it was a very valuable tool to kind of determine whether solar panels or solar feasibility would work for this location.
And part of the reason we wanted to show that as another emerging technology is a few different reasons. One, it did include multiple technologies, and we are actually continuing to push the envelope. I mean, this is bringing the buildings in, in this format. But it not only looks at sun studies, which again, relating back to campus, if there were to be campus planning or whether it's pedestrian access, et cetera, make sure we're looking at another tool that could bring in, again, using LiDAR technology, or there are drone capabilities where we can collect that LiDAR data, as well as we also could use our drone in instances like this. I know we're using one where you could add more visualization. We could add more color to this thing and make the buildings look the way they need to, et cetera. The sky's the limit. This was for a very specific purpose of looking at a sun study, which we thought would again be applicable to campus, especially with planning, making sure we're, maximizing views, but also just showing how, from a model perspective, it's very complex, but it's also somewhat rudimentary with block buildings, et cetera. But then you can drop in a Revit model, look at that, or we could add rendering, full visualization of the buildings. We could add drone imagery so that you could go in the building and look out of it. So just kind of we thought a good way to wrap up to tie a lot of those together and show another cool technology that we've been working on. So with that, I don't know if we fully mentioned, and hopefully people are still listening, that there is the giveaway at the end, which I will let Aaron maybe describe. But any questions? Again, please post them. Hopefully this was beneficial for everybody that was able to join in. Again, we ran through a lot of technology and a lot of data in relatively short order, but hopefully it did resonate well with perhaps some examples of whether it's GIS or facility asset management or any of the above. Some ways that potentially become used to be more efficient on your campus or push things forward or what have you. So again, any questions, feel free to post them to this, and I'm sure Eric can chime in. Any that come in, we can make sure we get responses to. I don't know if there are any posted now, and then I don't know if you got the rundown of how to enter to win, and I don't know if we said this at the front end, but is it as easy as reading this, Aaron?
I guess so. We wanted to kind of have some kind of door prize at the end there. So, if you, just respond to that link or text to that ISGRP and that number, and you could, win a $50 Amazon gift card.